Hello, welcome to Jet Mathematics. I remain your host, Milt in Ibiwa region. We are looking at simultaneous equation, and today we are solving three equations with three unknown. And we will be using the Crammer's rule, or otherwise called the determinant method. To solve this problem. Okay, so quickly we have the three equations 1, 2, 3. I'm going to represent them in a matrix system. So quickly we represent this in matrix system. We take the coefficients of the unknown. Here we have 1 for x, here we have -1 for y, and here we have the coefficient of z to be 3, and here we have the coefficient of x to be 1, here we have the coefficient of y to be 1, here we have the coefficient of z to be 6, here we have the coefficient of x to be 3, the coefficient of y to be -2, and the coefficient of z to be 2. So we represent this x, y, and z equals to 5, 12, and 10. So we've been able to represent this system of equation in matrix form. Next, we are going to find the determinant of this matrix, this one here. But then before we do that, I'm going to write 4 matrices that we are going to look for their determinant. So the first matrix is this matrix here. I'll call it A0, which will be 1, 1, 3, -1, 1, -2, and then 3, 6, 2. Then my second matrix will be A2, which I will call, remember, I'm going to replace this column with this column matrix on the right hand side. So here becomes 5, 12, and 10. I'm replacing this with this, and then I write this back. I have -1, 1, -2, and then 3, 6, and 2. I'm going to have another matrix A. So this A1. So I call this one A2 this time. So you can use any variable as you want. A2 is I'm going to replace this second column with this column matrix here. So I'll have here to be 1, 1, 3. Then I'm replacing here with this. So I have 5, 12, and 10. Then this remains 3, 6, and 2. Then the last matrix I'm going to get is A3. That is equal to, now we are replacing this last column, the third column, with this. So we'll have here to be the same, 1, 1, 3, and here to be -1, 1, and -2, and then here is replaced by this, and so we have 5, 12, and 10. So our next job is to find the determinants of these 4 matrices as we have here on the board. So in our last video we did how to get the determinants of matrices, a 3 by 3 matrix. So we'll just apply that method and get the determinants of this matrix. Okay, so quickly we'll get for A0, the determinant of A0 is equals to. So we take this number here, 1, and then 2 times 1 is 2, minus 2 times 6 is 12. So here becomes minus becomes plus 12. Now, in case you don't know how to get the determinants of a 3 by 3 matrix, I'll refer you to our last video on determinants of a 3 by 3 matrix. Please watch that video, and I believe you get a vivid knowledge, a good knowledge on how to get the determinants of a 3 by 3 matrix. So we use this, we get this, then we use this minus, then we have another minus 1, so this becomes plus 1, and then we have 1 into, and that gives us so we are blocking here and here. We have 2 times 1, 2, minus 3 times 6. 2 times 1, 2, minus 3 times 6 is 18. And then we have this last one to be 3, and here to be, this time this is minus 2, and this times this is 3, so we have minus 3. So this gives me 12. 12 plus 2 is 14. 14 times 1 is 14, plus 2 times 18 is 36. 36 minus times 1 is, 2 minus 18 rather is minus 16. And then minus 16 times 1 is minus 16. Then this times this is, this plus this is minus 5. Minus 5 times 3 is minus 15. So our answer here is 14 minus 16 is minus 2, minus 2 minus 15 gives us minus 17. So that's for our A0. So we're going to look for the determinant of A1. The same method for A1. We start with 5. We have 5 aside. And then we have 2 times 1, 2, minus 2 times 6 is 12. So that becomes plus 12. Then we take the next sign here, which is minus. Minus becomes plus 1 into 2 times 12, 24, minus 10 times 6, 60. Then we have plus, we have 3 into minus 2 times 12, minus 24, and then 10 times 1, minus 10. So we simplify this and we get 12 plus 2 plus 12 is 14. 14 times 5, 14 times 5 is 70, plus 24 minus 60 is minus 36. Minus 36 times 1 is minus 36. Then minus 24 minus 10 is minus 34. So minus 34 times 3 is 102. We have here minus 102. So our final answer here will be 70 minus 36 minus 102. That will give us, let's see, this and this gives us 138. 138 minus 70, that gives us 8, and this gives us 5 or 6. So I think we have minus 68. Okay. Next, we go to determinant of the A2 matrix, which is this. So we start with the first element, 1, positive 1, and then we have here 2 times 12 is 24, minus 10 times 6 is 60, minus, this is a positive number, so it's minus 0 minus 5, into, we have 2 times 1 is 2, minus 3 times 6 is 18. Now we have plus, here we have 3, into 10 times 1, 10 times 1 is 10, minus, and then here we have 3 times 12 is 36. So when we simplify this, we are going to get this minus this is minus 36. Minus 36 times 1 is minus 36. Then this plus this minus this, 2 minus 18 is minus 16. Minus 16 times 5. Let's see that 16 times 5. That is 0. Okay, so that gives us plus 80. And then here we have 10 minus 36 is minus 26. So 3 times minus 26. 26 times 3. That gives us 78. So we got minus 78 there. So final result here will be 80 minus, that is 2. 80 minus 78, that is 2. Minus 36 plus 2 is minus 34. Minus 34. Wow, that's quite easy. Then lastly, we have A3. The determinant of A3 will be, take the first element 1, and then we have 10 times 1, 10, minus 2 times 12 is 24. So that changes to plus 24. Okay. Then the next element here is minus, with the original minus that will follow, that become plus 1. And then we have 10 times 1, 10, minus, then we have 3 times 12 is 36, I think. Okay, plus 5, bracket, Then we have minus 2 times 1, minus 2, then minus 3 times 1 is 3. Okay, so this gives me 10 plus 24 is 34, times 1 is 34. 10 minus 36 is minus 26, times 1 is minus 26. Then minus 25. So that gives us, I think that should be this, and this is minus 50, minus 51. 34 minus 51, that should be minus 17. Alright, minus 17. So our last job now is to get our variables x, y, and z. So to get x, we say is determinant a1 over determinant a0. That gives us minus 64 divided by minus 17, and that gives us 4. So our S value is 4. So let's see y. Okay, y will be a2, the determinant of a2 over our a0, and that is equals to our a2 again is minus 34 over minus 17, and that is equals to 2. Wow, pretty easy, right? And lastly, our z will be equals to a3, the determinant of a3 over a0. That's equals to minus 17, which is this, over minus 17, that's equals to 1. So therefore, x is 4, y is 2, and z is 1. So these are the results. When you substitute them into those equations, you certainly get the right hand side. Alright, we'll stop here. Please don't forget to like, to share, and to follow this page.